may I have your attention? Please welcome TechCrunch Managing Editor, Matt Burns.
What a morning! And this is the best part. Serena Williams, Kevin Hart, and now Startup Battlefield. Thank you all for being here. I'm excited. I hope you were here yesterday. If you weren't, I want to bring you up to speed. We had robots. We had implantable heart monitors. We had AI-generated content for ad copy. We had smart, quick flashcard makers for students. It was wonderful, and we're going to have more of the same today. So I want to review the rules real quick. The companies have 6 minutes to present, and they're going to get 6 minutes of questions and answers. You, the audience, I need you to bring the energy. These startup founders have worked so hard over the last 6 weeks to perfect their demos and their pitch, and they need that energy to thrive. So when we clap, you're going to clap hard, okay? With that said, we need to bring out the judges. We'll get this thing going. Okay, number 1, as I read their bios, we have Jameson Hill. Jameson Hill, partner at Base 10 Partners. He's as a partner to lead the advancement initiative after spending 7 years at Bain Capital Ventures, where he led growth investments into marketplace businesses, leading software companies and fintech companies. Prior to Bain Capital, Jameson was an early employee at Bonobos and started his career as a management consultant at Bain Capital. Next, we have Charles Hudson. Charles Hudson is the managing partner and founder of Precursor Ventures, an early-stage venture capital firm focused on investing in the first institutional round of investments for most of the promising software and hardware companies. Prior to founding Precursor Ventures, Charles was a partner at Softtech VC. Next, we have Dave Municello. Dave is a GV's general partner who leads the firm's digital investment team, spanning its consumer and enterprise and frontier practice areas. He prioritizes time spent building long-term relationships with technologists who pique curiosity, drive, and vision. Dave himself is deeply curious about data platforms, data science, developer tools, infrastructure, and enterprise software. Next, we have Emlyn Shaw. Emlyn co-founded Flourish Ventures, a $500 million global venture firm that invests in fintech and purpose. She leads the U.S. portfolio team and sits on boards of Unit, Kin Insurance, SeedFi, Clerky, and Cushion. She led the firm's investments in and provides guidance to Bright, Chime, and Propel. Last, we have Milo Werner. Milo is a general partner at The Engine. She serves as a board member for Mori, Atlantic Quantum, and Foundation Alloy. She sits on the boards of UVM College of Engineering and Mathematical Science, Axel Hire, Informative Electric, and a board observer online. Previously, she was at Ajax Strategies, where she was a partner, leading mid-stage investments across energy, transportation, agriculture, and industrial applications. Give them a round of applause. Thank you for being here, guys. So once again, we're going to bring out 5 companies during this round, and then later in the day, we're going to have 5 more companies. After today, the TechCrunch editors are going to narrow down the 20 companies you saw over the last 2 days to 5 companies who will present again tomorrow to a new round of judges. But let's get this round started. First up, from Bellevue, Washington, we have Ally Robotics. Presenting for Ally Robotics is Mitch Tolson and Jennifer Christensen. Come on out.
I was a laborer. Everything I know about the future of robotics comes from my days working on the manufacturing line and the job site. I think about how I learned how to lay brick, wire electrical, and frame a house. People showed me how, and we used the right tool for the right job. I've worked on robotics projects for over 20 years, and I've repeatedly asked, why can't robots learn the same way? Why are they so expensive and difficult to train? So why is this important now? There is a labor crisis in the US across the construction, agriculture, restaurant, and manufacturing industries, having a $1 trillion negative impact on the US economy. So what do? Robotic innovation has focused on factory automation that doesn't translate well to everyday automation. These industrial robots have big external control boxes with difficult to manufacture strain wave gears and legacy PLCs, limiting where robots need to go in the future. These robots are also focusing on costly, extreme precision. Let's say I want to cook French fries or install solar panels. I don't need plus or minus 0.01 millimeters of repeatability when 1 millimeter is good enough. We must create the right tool for the right job. Introducing the Ally Arm. With a combination of machine vision, imitation learning, AI, and hardware innovation, we can significantly expand the market for robotic technology and everyday automation. So how do we do this? We've opted for proven planetary gears that are 97% efficient and 20% the cost of strain wave gears. We've removed the external control box, and you can power the Ally Arm from a standard 110 AC outlet, or for those in mobile applications, natively 48-volt DC. We've developed a novel joint that allows us to put more electronics into the base, improve wire routing, and mechanically couple joints 1 and 2 for smooth motion, double the torque at no velocity loss. We've even invented a quick change actuator. Now, anyone will be able to service the robot just like replacing the batteries in your flashlight. We even use something called the endoskeleton-based design. So think of a human arm. You have your skeletal structure, you have skins. Just the same, we have robotic skins that can be adapted to the application requirements. So whether your scenario is clean food automation or pulling recyclables from a landfill, we have the skin for you. The opportunities are endless. The most challenging aspect of robots today is they take hundreds of thousands of dollars to program and train by experienced professionals, greatly limiting automation for everyone. Until now. The Ally Arm is both smart and simple. What you're seeing here is just the beginning of translating human gestures into robotic motion. Oh, here we go. There we go. We even have control over the end effector and other devices connected to the arm. I started the company 9 months ago, and what you're seeing here is 3 months of our effort. When we are done, even my 5-year-old will be able to program the robot by showing it, and the robot will then repeat that task. There it goes. So this is what we call a micro behavior, and you can create a bunch of these. Grabbing cups, grinding, sanding something, and then you can repeat that. The Ally, can I go to slides? The Ally Arm is the first robotic arm designed from the ground up with AI and learning at the core. We are collaborating with NVIDIA to adopt the Isaac platform for edge compute, AI, and simulation to accelerate our development and provide the best development tools, not just for developers, but anyone. We also have customers. We have a $30 million letter of intent with Miso Robotics, and we have $400,000 a month in monthly services from Bobacino, Ryko, and others. The Ally Arm is the smartest, most affordable, easy to service, and simple to train robotic arm, and together, we're enabling robotics for anyone, anywhere. Thank you.
Mitch, that was wonderful. 9 months and we're here?
Yes.
That's great. All right. Well, Dave, let's start with you.
Yeah, sure. So prior to my time at Google Ventures, I was at a company called Kiva Systems, automated warehouses with robots, and have spent a bunch of time thinking about sort of the balance of specialization with robotics and being more flexible. It seems like you've erred towards being more flexible, able to be trained by humans.
Yes.
Does that change the way that you go to market with a company? So if a company's really excited about purchasing your robots, working with your robots, don't they require some sort of specialization, integration, specific training for their workflows? And how do you think about the balance between specialization and more general approaches?
Well, I'll start and then
great.
add on to me. So I do not have any programming background. I have an engineering background, but skip the programming side. I train it via, right now, sign language, right? It's a step to where we show the robot what we want it to do. So down the road, we would take the arm and I would just pick up the brick and move it, and it would do that. So as we go into any type of workflow situation, it would be similar. If someone needed something different, of course, we'll work with a customization piece to that. But otherwise, it will really be as simple as showing it what you want it to do. You want it to grab from that shelf and move it over there. You want to move it from that bin to that bin. You don't need a technical background to be able to do that. So it's part of the anyone, anywhere, concept.
And just given that, can I ask a follow-up? Sorry. And just given that it's generalizable, are you finding that often the applications are similar to what a human would be doing? Is that the alternative?
Absolutely, right? I mean, so when we look at cooking French fries, for example, if I'm standing in a quick service restaurant, I'm having to grab the basket probably with two hands. I have to shake it, I'm around the oil, I have to make sure I'm hitting the timer, helping people doing these other things. A robot does that so much better and can do it consistent, and my background's in ergonomics, so you don't have to sit there and do that. The robot can do that. I can focus on managing the process, helping people, and doing what we're better at as humans.
Cool, thank you.
I did French fries at Wendy's, and I was pretty good at it. Jameson, let's go to you.
Yeah, thank you. Remarkable for 3 months of effort.
Thank you.
I'm curious, with the sort of initial customer set that you're talking to, can you speak a little bit about implementation? And I'm particularly curious about time to value, and then also how much behavior change is required on the part of the customer.
Take that one.
So first, before I started Ally Robotics, I wrote a white paper on why robot companies fail. The key thing there is I saw my research showed a lot of companies don't focus on the customer.
That's right.
So that's how we started. We first found the customers, deeply understood their problems that they want to go solve, and then we've taken those sort of, here's what market and industry technology is not doing, and here's how we can go about solving those. So when we look at food automation, this is where we're starting. It's what are the intrinsic things within this environment, and how do we develop an architecture that scales beyond food automation when we're solving for food automation initially. So as an example, our endoskeleton design with the shells, in clean food automation, you need NSF 169 certified skins, but that's going to be a little bit more expensive for that type of skin, right? But if I'm putting this arm in some other environment that doesn't need IP65, why pay for that? And so that's kind of the little bit of the integration effort that we're doing.
Terrific, thank you.
Milo?
Yep. Great work, super impressive. You're not the first ones to try and crack this nut. Think of Rodney Brooks, phenomenal roboticist out of MIT, founded iRobot.
Yeah.
His next company was Heartland Robotics, right?
Yeah.
And that was a multi-purpose robot that was meant to work alongside people and easy to train. Very similar.
Yeah.
Could you just talk a little bit about how you feel you're solving this problem in a different way that's going to be successful?
I'll build on what I said just before. It really starts with our initial set of customers and designing to that first that allows us to solve their need immediately, bring in revenue, and then integrate and implement to solve their issues and their challenges incrementally. So it's things like, we're not trying to tackle all the problems all at once. For example, with Minerva Robotics, they have an opportunity, a new client of theirs might come in and say, hey, I want to cook a different style of French fries, right? And I need a different dwell time and I need a different behavior. So it's then we focus then on the problem of how do we help them speed up the training of that behavior with visual training? And then it's a discrete problem to solve, and then over time, these solved discrete problems amalgamate into a larger set that's more agnostic.
Great, thank you.
Charles?
Can you talk a little bit about cost profile and the payback period for your customers? How they think about ROI?
Sure. So we have not set pricing yet. That will come as we move towards manufacturing and have that. But we have kind of two paths for customers right now that we're envisioning. One where they could purchase the arm or arms, multiple outright, or they could do robots as a service, and we would work with them on, monthly, yearly, whatever that may be. The return period, part of our pitch is that it's affordable. So that's a big piece of what we'll be trying to drive home and competitive with our customers. But as we move forward, we will also we'll have a return period, but the money that we get net is all going to flow right back into Ally because we want to be able to scale and grow and go faster. So
Thank you.
Thank you very much. That ends our time with your company. Appreciate it.
Thank
Give
you
them a
very
round
much.
of applause.
Yeah. Thank you.
Okay, next up, all the way from Argentina, we have Netflow Bio. Presenting for Netflow Bio is co-founder and CEO Joaquin Fish. Come on out.
All right.
Go ahead and start. Oh, if we can start the slides, please, and reset the clock.
No.
That would be lovely.
All right, so we all know that food waste is such a huge issue. In fact, if it were a country, it would be the third largest greenhouse gas emitter after China and the US. Almost 30% of all food produced is lost or waste every year. And this is worse for fruits and vegetables, where almost half of all that is produced goes uneaten. Now, imagine a perfectly looking and juicy lemon waiting for you at your grocery store. This lemon had to go through several different stages before arriving at the shelves in perfect conditions. And most produce is not grown everywhere in the world, so they have to be shipped over long distances. Now, how do they arrive looking like this instead of this? Well, that's partially thanks to pesticides, which take care of biological spoiling factors, such as the attack of microbial pests, and waxes and coatings, which help in retaining weight, moisture, and flavor. But the problem is that currently used pesticides are synthetic compounds, which are harmful to human beings and the environment, so they are being banned. And even though there are natural waxes available that might come from plant or insect compounds, scaling up these solutions is a real challenge. My name is Joaquin Fish, and I'm the co-founder and CEO of Netflow Bio, where we harness the power of microbial fermentation to protect our food. Our coatings are based on biomolecules produced by non-GMOs, which were isolated from nature. These coatings are transparent, odorless, and tasteless, so they don't alter the customer experience. How does it work? The coating is made of a glucose-based biopolymer produced by fungi and naturally occurring antimicrobials produced by different strains. We combine the biopolymer with food-grade excipients, forming a coating that regulates the gas exchange between the fruit and the environment, delaying the ripening process. The coating also provides a structural matrix, preventing the drift and enhancing the delivery of the antimicrobials, allowing us to use very little doses of these molecules and still get meaningful results. Even though the coating is fully edible, it can be easily washed off with water if desired. Our MVP is a food-grade coating for citrus, and we perform curative tests by first infecting lemons with a concentrated solution of penicillium and then applying the coating. As a result, our formulation showed to be as effective as the most commonly used synthetic fungicide in citrus. And this means that our customers will be able to market their produce as zero chemical residues, capturing a price premium and without compromising decay control. A similar formulation also showed a good performance protecting berries, and our coating also extends the shelf life of produce, like climacteric fruits like avocados, gaining up to 5 days of shelf life in ripening chambers, reducing 15% the weight loss, and increasing firmness and browning, which are all big concerns in long value chains. Now, considering that our product cannot be seen fighting infections in real time, we prepare a time lapse as a demo. So what you can see here is a lemon being infected by a strain of penicillium and start dehydrating. Look how well the coated lemon retains the color and moisture, And after 21 days, there are no signs of infection whatsoever. But there is a thing we can see in real time. So 8 days ago, we launched some avocados, launched some tests on avocados at the lab, and now we're going to cut them in halves in live so we can check the pulp. So close-up camera, please. Let's switch to the close-up camera, please. Yeah. As you can see, there's a clear difference in coloration between the green ones, the coated ones, and the uncoated ones. At the camera a bit higher, please, Emma. Yeah. And now cut it in half, please. This is like Schrödinger avocados. They are both green and brown at the same time. So the pulp on the coated avocados are far more greener and firm than the uncoated ones. And this is purely the effect of the product. All right, so let's get back to the deck, please. Regarding our traction, we have 3 R&D agreements with citrus packers, potential customers for our MVP. And now we are already field testing on lemons in Argentina. So this is an actual video of our product being applied in the facilities of one of our partners. The product integrates seamlessly with existing machinery, so there is no need to invest in special equipment. The market potential for this technology, we estimate that it's a $3.5 billion opportunity, but initially we're targeting the most exported fruit classes in Latin America, which are citrus, avocados, and berries. And apart from traditional chemical companies, some competitors provide shelf life extension, but no natural protection against microbial pathogens. And there are other competitors focused on biological control as well, but they use living microbes in their formulations, which require special storage and logistic conditions. Our cell-free formulations are stable and can be easily stored. We are a science-driven team, and our team has extensive expertise in working with microbes, the compounds they produce, and their applications for the agri-food industry. And our next steps are finishing field testing and having the MVP ready to scale up, securing and protecting our IP, and continuing screening our culture collection for promising microbes and biomolecules. At Netflow Bio, we want to help fight against food waste and food insecurity without compromising human or planetary health. And we are looking for partners to help us test and scale up our technology. So please go to netflowbio.com and drop us a message or pay us a visit on booth L7. Thank you very much.
Wonderful. Emlyn, let's start with you.
Great presentation, first and foremost, and thanks so much for pulling up the competitive slide. Folks like Appeal and Movie have been around for quite some time. Appeal, in particular, a pretty well-funded competitor of yours. They too claim to be, non-GMO, use monodiclyserides. I'm curious, how do you think about? You'd mentioned the difference being the natural antimicrobial. What is the value proposition? And as you think about the top 3 things that ultimately suppliers care about when making that buying decision, how do they think about that trade-off? How does it translate to price, availability, et cetera?
Well, that's a good question, and it has several different answers. So first, regarding our difference against coatings that extend shelf life of produce, this having the ability to effectively replace synthetic pesticides is a huge value added in the midstream. Not so much from a consumer-facing standpoint, because the product, it's arrived at the shelves after a lot of different stages. But from having, for example, a packer that can replace a synthetic pesticide, it can be a way to unlock new markets that are very demanding in terms of how many synthetic molecules you put in the food, and also capturing this price premium from the zero residue market, which is an in-between between conventional and organic produce market. Following up with the other part of the equation, according to our customer discovery process, there is a huge need in replacing these synthetic compounds. But the problem is that there hasn't been a lot of innovation in the post-harvest stage. So pre-harvest, crop protection is packed with amazing companies doing a lot of biological control, but in post-harvest, this is not the case. So we are capturing an opportunity, which we know we think is a huge game changer for a lot of companies.
Thank you. Milo?
Yep. Great work, super exciting. Can you talk a little bit about the application process?
Yeah, so the good thing about the formulation is the film forming properties. So this translates into a liquid that when it's sprayed, it has a very strong capability of forming a film around the fruit. So that is actually what ultimately provides the optimum protection for produce. So we are testing, of course, this is the first time we left the lab bench. So it's going to take us some iterations to iterate with our partners. But field tests are going great, and the product is showing good progress and good function. So it's just spraying. It can be also applied by a dip or submersion application, which is not optimal in terms of yield coverage from our standpoint because it requires more product per ton of fruit, but it can be an option as well.
And are you thinking it's going to be done in the field, at the packing facility,
Yeah, we enter the value chain at the midstream, which is the packing lines between distributors and after farmers.
Oh, interesting.
Great question. Dave?
Yeah, I never imagined that we'd be talking about avocado weight loss in this setting, so quite interesting. Curious to know, so in those lines that you're talking about where the application is done, are they already applying things to fruit and vegetables in that kind of process today?
It depends. On citrus, there is a heavily automated packing lines for treat citrus. Avocados, it depends on the customer. Some of them have facilities to apply a liquid, spraying liquid, and some of them don't. And regarding blueberries and strawberries, this is a kind of heterogeneous because some of them, for example, very demanding and fast-paced market, actually puts the produce in the clamshells in the same field, and they pack it in 7 or 10 days. It's arrived to a U.S. customer, for example, for a Chilean producer. So it really depends. We're trying to make a one-size-fits-all formulation, so we can grab the most sizable part of the market right away, and then start iterating in maybe more specific formulations.
Thanks.
Jameson?
Could you talk a little bit about sort of early customer conversations? What do customers really care about here? And then have you done any exploration around pricing?
Yeah, that's a very good question, and that's something that we are doing right now. We are pretty much focused right now on having a functional product that can provide us a good level of protection by using the same existing equipment. So far, we haven't discussed price yet. According to our unit economics, we may be able to cost less than 0.5% in their cost structure, and in exchange allowing them to capture this 10 to 15% price premium. So from an exchange standpoint, it closes for them. It's good for us. We can produce our media culture goals is negligible. Sorry. So it costs us very few dollars per ton to produce our compounds. But yeah, there's something that we have to do.
Great.
Still.
Great. Last question goes to Charles.
I just really enjoyed the presentation. How hard will it be to expand beyond citrus, and how generalizable is the technology? We think about other. You alluded to this, but I'm just
Great question. Yeah. First one is we call pathogen fit, in which we have to have a molecule that can control effectively this pathogen. The antimicrobial we use has a very wide mechanism of action, so it works against pathogens like blueberries and strawberries, anthracnose in avocados, also both penicilliums in citrus. So we don't have to explore for another molecule. In terms of the formulation, it all comes down to the application equipment. So if the customers use a spraying application, the base formulation would be a slightly more different than if they use an electrostatic application, which is used in more fragile fruits like blueberries or strawberries. And that is a thing we are still on the development phase, but we're getting it. We're getting to it.
Thank you. Well, thank you very much. Give them a round of applause.
Thanks.
I feel like avocados are aspirational foods. I buy a lot of them, and I always aspire to eat them, but I never do. Okay, next one up, number 3, we have Minerva Lithium, coming to us from Greensboro, North Carolina. Presenting for Minerva Lithium, we have Shiba Daewoo and Hermali Brathnica. Come on out.
the whole world is transitioning to clean energy, due to which the energy storage market is expected to increase in billions in next coming years. Minerals are fundamental for clean energy transition. And earlier this year, President Biden announced to bolster critical mineral supply chain for minerals such as lithium, which is expected to increase more than 4,000% in coming decade. Lithium is primary component in battery, and battery industry is expected to reach $183 billion by 2025. And this requires 1 million metric ton of lithium. There are various resources of lithium, and the primary ones are hard rock and brine. Mining lithium from hard rock is pretty much what you think it could be, very similar to traditional ore mining. On the other hand, brines are the natural resources of lithium which are present in the form of salt lake, continental brines, and oil field brines, constituting 66% of total global lithium resources. Solar evaporation is a current technique that is used to extract lithium from brine. In this technique, water is pumped into large ponds, about 20,000 acres, and allowed to be evaporated for 36 months. And to just produce 1 metric ton of lithium, they use up 500,000 gallons of water, releasing 5,000 kilograms of carbon, with a production cost of $6,000. So what we see here, that we have enough resources of lithium, but lithium brine industry lack efficient lithium extraction technology to meet the current demands of exploding battery market. Addressing these challenges, Minerva Lithium have developed direct lithium extraction technology using nanotechnology. Our company was founded from my PhD project. During my PhD, I was able to develop nano-mosaic absorbents, which are very similar to sponge. These sponge-like materials are chemically and physically designed to just attract lithium, rejecting all other minerals. So taking advantage of the selectivity, our process is just two-step: extracting lithium within 48 hours and process it into battery grade. And to produce 1 metric ton of lithium, only 30,000 gallons of water is used, with a production cost of $1,000 with zero carbon emission. Let me show you the demonstration of our product. These are our nano-mosaic absorbents, which are made at room temperature. And these are our filter units, which are 5 feet long. In the first step, we add nano-mosaic absorbents into the filters. In the second step, we add the brine that contains lithium. After soaking for 24 hours, we collect the brine to evaluate the amount of lithium absorbed in the sorbents. ICP is an instrumentation which helps to measure and identify lithium. From our results, what we have found out that as the time increases from 0 to 25 hours, the efficiency of lithium absorption increases from 40 to 95%. And later we dissolve and convert into battery-grade lithium. Let me show you the product physically. These are made at room temperature from naturally available polyphenols. And here is our filter units. Which can treat almost 171 gallons of water per minute, extracting 2 metric tons of lithium per day, which is $40 million revenue per year. Our current customers are lithium brine operators. From lithium industry and petrochemical industries, capturing market about 1% of global lithium market, which is $13.5 billion by 2025. So comparing to traditional technologies and also recently developed direct lithium extraction technology, our company offers competitive advantage in terms of cost and efficiency. We are a team of scientists and engineers with former CTO of Halliburton serving as business advisor, former CEO of automotive industry serving as chief operating officer. I am Shiba Dawood, CEO and co-founder with PhD in nanoscience. Hemali Ratnaika is a co-founder and associate professor in nanoscience. So Minerva Lithium, with its disruptive technology and outstanding team, aims to provide sustainable energy technology to the global market. And this technology is not just limited to lithium extraction, but can be extended to various chemical extraction like nickel and cobalt. So if you're someone from clean tech space interested in investing or collaborating, sign up for Minerva Lithium. Thank you.
That was wonderful. I love your energy. Are you hiring? Okay. Emmeline, let's go to you.
First of all, so exciting. This is a really innovative space, and I know it's actually relatively early as you think about the ecosystem. I'm curious, though, there are folks who have been innovating, EnergyX probably being the one that's closest to home out of Puerto Rico. And what they found when they were actually speaking with the lithium operators was they actually needed to take their membrane technology and actually create units so that they could be within the ponds, because the pond operators weren't going to change their format. I'm curious, how do you think about your go-to-market strategy? What have you learned? And how do you think about your own go-to-market and pricing relative to competitors like EnergyX and others?
Yeah. So what we thought our go-to-market strategy is exactly, our customers are brine operators who already have inbuilt infrastructure to, to carry out the operations. So we would install our membranes, or we would customize our membranes based on their infrastructure, and that is how we are looking forward to move forward. And also regarding the pricing, we have compared to the solar evaporation, which is a traditional technique, and also the recently developed direct lithium extraction technology, and we are almost like 5 times cheaper than what they do.
Jameson?
Yeah, thank you. Fantastic presentation. And I just think the cost differential between the traditional way of doing it and what you're doing is remarkable. I'm curious, what are the biggest barriers to scalability today in terms of being able to produce the amount of lithium that we need?
Regarding the scalability, the first thing would be, I would say that the material itself, we require huge reactors, and that is why we are here doing fundraising. So where we require at least $1 million or so, where we can create these large reactors to do the extraction process. And otherwise, we as such, we haven't come across any kind of barriers. But I would say, again, the geographical location would be one of the barrier, because not everywhere we see brine operation taking place. Yep. So that could be one of the huge barrier for us.
Terrific. Thank you.
Milo?
Yeah, I have 2 questions. First of all, great work, super exciting. It's going to be a huge market, and there's going to be, I think, a number of technologies that are successful in solving the lithium shortage that we're going to face. So question number 1 is, could you talk a little bit about the reverse process, the process for pulling the lithium out of the filter?
Yeah, I can answer for that. And so after we send the brine into the filter, and so the desoak process is taking about 24 hours. So we use acidification, but we use our proprietary active acidification materials to desoak. And so the desorption is take place about 24 hours. Then after that, we can take it to a 90% recovery efficiency. And after we take lithium-rich brine out, and then after that, we convert that into with our process that developed with the Minerva Lithium, convert that into PO 99% purity with battery-grade lithium carbonate. So that product also is able to sell to the battery manufacturers directly.
And a number of the competing technologies have talked about being able to work with brine that is less pure, right? So like right now, a lot of the extraction's happening in South America, but in the US actually has some of their own lithium resources, and looking at how we can extract those. Could you talk a little bit about like if you have any purity requirements in the brine?
Yes, so it's usually the most of the technologies we have out there in the direct lithium extraction processes. So you need to have a high lithium concentration brine in the first place. So that's where our technology is coming very unique. So this technology, you can extract the lithium even the very low concentration of the water to high concentration. Now, for example, the Energy X, if we talk about their technology, they use the membrane technology, but you need to start with the lithium-rich brine concentration, about 2,000 parts per million of lithium concentration to go through the membrane. We are not restricted by that the concentration. We can go from 100 ppm, for example, if there is a seawater, we can get seawater, even we can get the lithium out from that while we recycle in the seawater. So it is the extra benefit from there, and then you can go up to about 2,000 concentration. There is no limitation in the concentration with our technology.
Fabulous.
And then the converting that lithium-rich brine into a lithium carbonate. So our process is 99% purity. So that's where also we can adapt some of the lithium brine resources people. Then they have this lithium-rich, but they have a technology lacking the technology that converting into a lithium carbonate into the high purity. We can also fit in that market segment also.
Dave?
Wonderful.
Yeah, and this is an inspirational story. Really, really interested in this technology. I'm curious. The lithium mining market is, it's all over the world, and also, you're talking about a massive market where there are a lot of players who could make a lot of money over technology like this. Curious, do the patents that you would need, do they apply to the locations where most mines are? And how do you think about protection on your tech against all of the other chemicals companies that would want to be in the space?
Please keep it short.
So currently, the patent, we do have our own patent, which is fully transferred to our Minerva Lithium. And regarding the geographical restriction, yes, some states have different rules and regulations, and that is where we would be facing some of the limitations and restriction there. But what we are trying to do is trying to develop or have a strategic partnership with the brine operators, and that would give us feasibility to kind of have a joint venture with them.
Well, thank you very much. Give them a big round of applause.
Thank you.
Next, from Munich, Germany, we have Revion. Presenting for Revion, founder and CEO Stefan Hermann and Ada Fernandez. Come on out, guys.
Imagine we were living in 1948. In 1948, our pitch could have started with a quote like this. But since we're living in 2022, the vast majority of people on our planet has bigger problems than sports cars. I mean, way bigger problems. We are facing global warming and a war-derived energy crisis with skyrocketing energy prices. Still, we are producing up to 85% of our global energy demand through combustion-based power systems burning fossil fuels, a technology that's essentially still the same as in 1948. These combustion power plants fail. They are highly inefficient, they are not flexible, and they emit millions of tons of CO2. So still in 2022, we could not find the power plant we dreamed of. So we decided to build it ourselves. We are Revion, and we have developed a true game changer in power generation. Our solution produces power at a groundbreaking efficiency of 80%. It is fully reversible. It is plug and play, and it even has a carbon negative footprint. Let's have a look inside. Our technology combines three major building blocks in a new and unique way. The heart of the plant is a solid oxide fuel cell module. The fuel cells produce power without combustion, but through electrochemical oxidation. To this, we add a CO2 separation unit and a methanation reactor. But why is that so much better? Conventional power plants, like this internal combustion engine, produce power at a poor efficiency and emit vast amounts of off-gas to the atmosphere. they are inherently limited in efficiency by the combustion process through thermodynamics. Existing power plants using solid oxide fuel cells, like the very same that we are using, have a bit higher efficiency, but still emit their off-gas to the atmosphere. Their efficiency is, however, not limited by the fuel cell thermodynamics, but by their system design. I analyzed these systems in detail during my PhD and found that the main reason is incomplete fuel conversion in the fuel cells. This leads to a fuel loss of up to 30% through, again, simply burning it. This is the main thing that we have changed. In our Revion units, we have eliminated the combustion completely. By adding the two components that we showed before to the fuel cells and operating the system in a closed cycle, we achieve 100% fuel conversion and 80% electric efficiency. On top of that, there is no off-gas anymore, but we just produce water and pure CO2, which now becomes a valuable product. And finally, our new system design is reversible, meaning it can also produce gas from excess power. Biogas plants are our first target market. Here, when there is not enough solar or wind power in the power grid, we produce renewable power from the biogas while separating pure CO2. Long-term storage of this biogenic CO2, in turn, enables negative CO2 emissions. When the sun is showing up and suddenly the grid is flooded with renewable energy, we take excess power from that to produce either green hydrogen or renewable methane. This enables long-term energy storage. For our customers, the doubling in electric efficiency, first of all, means doubling revenues from electricity. With the additional revenues from the reversible operation, they can overall more than five-fold their income. So let's have a look at the real thing. We are live with my co-founder Felix in Munich, and he's now walking into our containerized power plant. First of all, to the right, you can see the CO2 separation. This is a pressure swing adsorption system that removes the CO2 out of our system. What you can hear is the compressor next to the CO2 separation that compresses the feed gas to about 3 bar. Next to that, there's our gas cleaning unit that protects the fuel cells from damage. Then there's a humidification system that increases the energy efficiency. And behind that, you can see our methanation reactor. And finally, there are the main heat exchangers that heat the gas and the air to the fuel cell operating temperature of around 600 centigrade, and the fuel cells that are packed into a thick thermal insulation box. Thank you, Felix. Move back to the presentation, please. One single of our Revion containers can provide up to 500 households with renewable gas and power, while separating almost 2 kilotons of CO2 from the atmosphere every year. 40,000 of these can equip all existing biogas plants in Germany, for example, and produce up to 30% of the overall German power demand, half of the last year's Russian gas imports, and reduce our overall emissions by 20%. Globally, by using the available sustainable biogenic resources, we can replace all fossil-based power plants, which is a $7 trillion market, and remove the equivalent of the entire US CO2 emissions from the atmosphere every year. In times of war, global warming, and extreme energy prices, join us to provide the world with decentralized, carbon negative, and highly efficient power plants. Thank you very much.
Thank you. Charles, let's start with you this time.
Really impressive. Can you talk a little bit just about deployment and how you roll something like this out?
Sure. So right now we are building all of these units ourselves. So we are in a phase where we're now putting pilots out. And this is, of course, nothing that we will do for a mass manufacturing. So as soon as we have a really design freeze for a series production, we will externalize a lot of the production. We are already in discussions with a lot of partners that will manufacture hundreds of identical sub-modules for us that we will just then put together, put our software on that, and then qualify and then put to customers.
Thank you.
Dave?
Yeah, I guess I'd love to go a layer deeper into all of the different, like, what are the connections that need to come into this box? And how do you work with the municipality in order to get the clearances to provide all of these connections into the box?
Yeah, good question. So you just basically need to plug in the gas line from the biogas and the electricity. The unit is fully automated, so it can just run. You just tell it, please now produce power, and it will just ramp up. And in terms of, how do you call that, permissions, we have already done field tests and run through all the permission process. So there's, in terms of emissions, noise, and so on, you have to qualify. And but we know the process, and at least for the German market for now, it will be different in the US and so on. But yeah, it's not a big problem because we are not emitting anything. There's nothing coming out that is hazardous to the environment. So actually, it's much easier to qualify our units compared to the traditional biogas plant that would have a combustion engine, because they have to stick to certain NOx levels and things like that, which are no topic for us.
Thank you.
Milo?
Could you talk about any IP portfolio that you have?
Right, yeah. We have 6 patent families that are covering basically different aspects and the whole system design. So the oldest ones are the system design patents that are already also regionalized worldwide, and the newer ones that are still in the PCT phase that cover basically upgrades to our design. Yeah.
Emmeline?
So incredible objective, and replacing all fossil fuel plants is just no small endeavor. Curious, as you think about which markets you would likely prioritize, and what's the greatest friction points in your mind as it relates to regulatory, et cetera, to determine the efficacy of what you're building?
Yeah, so in terms of target markets, Germany by itself is 40,000 units to deploy, so quite a way to go. And we try to keep it regional first because we also have to do maintenance and so on. But then, of course, finally we want to go worldwide. And the second question was?
Yeah, what do you think the biggest friction points are as the companies, the technologies being evaluated to determine that they'd be willing to open up and replace massive power plants today?
Yeah. Well, I mean, we are stepping up against the combustion engine market,
yes.
But since our technology is vastly superior and can generate much more income, there's not really a competition. So as it more depends on how much we can produce, actually.
Are there certain stakeholders that you need to sell into to get buy-in to ultimately replace this core infrastructure? I think is what I was trying to get at.
I didn't understand that.
Sorry, are there specific stakeholders that you really need to get buy-in from in order to replace this core infrastructure?
Yes, so stakeholders or our customers are basically all across the biogas sector. So from individual farmers up to big utilities. And well, they have different cycles in terms of sales and so on. The farmers are individually owning their plants, so it's really quick. And we have quite a few of them already signed up. And for the utilities, it's longer. And for municipalities, we don't have any customer relations yet.
Great.
Thank you.
Jameson?
Terrific. Thank you for the presentation. You know, it's rare to see solutions that have such dramatic impact, both from a sustainability perspective and from a financial perspective, you know, for your users. So kudos to you on that. I'm curious on the manufacturing process for creating one of these units. You know, how long does it take? How much does it cost today? And where do you see that going in future?
Right. So in terms of manufacturing, we are right now doing all in-house. I mean, of course, we buy things like blowers and so on, but integrate everything ourselves and weld all the containers, the cylinders that you see, and so on. And of course, as discussed, we externalize more and more of that. And the second part of the question again?
Just like the amount of time that it takes and the cost for a single unit.
Right, yeah. For the pilots right now, it takes a few months each. Yeah. But finally, we'll arrive for the series production, putting out like 2 to 3 to 4 to 5 to hundreds a week at some point.
Got it. Thank you.
Great. Well, thank you very much. I appreciate it. Give them a round of applause. Before we bring out the last company, just a little housekeeping note. After we conclude here, you have an hour break, and then come on back here. You're not going to want to miss this. We have OnlyFans coming back up on stage. So, with that said, let's bring out the last company. And coming all the way from the Netherlands, we have InCooling. Presenting for InCooling is Helena Somodeva, co-founder and CEO, and Rudy Verwey. Come on out.
In the last 2 years, we have created more data than the entire history of humankind. Now, our friend Gordon Moore correctly predicted that every 2 years, our computing capacity will double. It became smaller, faster, and more efficient over time. It was working until today, because today we are at a turning point. For the first time ever, our demand for data is bigger than what technology can handle. And it's not that technology is not there. It is, but we have a new issue, the heat. You see, the more you ask your computer to do stuff, it overheats. And as it overheats, it becomes slower. Every time during pandemic you had a Zoom or Microsoft call and it dropped, it's because a server somewhere in a data center simply overheated. Now, data centers have cooling solutions, but this heat is a new problem. And the solutions today are archaic and simply just not good enough. There is a solution in cooling. Our mission is to cool down the planet one server at a time. Now, the way we started was by partnering with the largest scientific experiment on the planet, the Large Hadron Collider located in Switzerland. Now, as a particle accelerator, they have these sensors inside the experiment itself, and they track the activity of the particles, and they needed cooling. It was quite interesting because it's located 16 meters under the ground, there's radiation, it's vacuum, and very, very high heat. And they themselves struggled with cooling, so they had to design their own two-phase cooling system. Now, what is two-phase? Two-phase simply means it's going from liquid state to gas state, simply like your kettle when you're making your tea, so it does the same here. The difference from air cooling or water cooling that's used today, this can allow us to go below ambient. That means we can go below room temperature, and that is no cooling system in the market can do that today. Essentially, what they built and what we're building is a fridge on the CPU. Now, by partnering with them, we realized there is a need in the data center industry, so we took the same approach and developed our own two-phase cooling system. And with our partners, we integrated it in our own InCooling server. Now, what does the server look like? Let's look to the demo. So, this is my team streaming live from Eindhoven in the Netherlands in a high-tech campus. As you can see, it's middle of the night there. They specifically came in to run the test, and show you how it works. So this is our server. It's a standard server. You can insert it in any data center today, so you don't have to change a thing. And inside is our magic cooling system. What we can do with this server is run a number of tests. So right now they're running a test. It's called Cinebench. It's modeling a 3D animation, how fast you can do it. So it works in engineering, movie industry, banking, and whatever. So the important thing to look at now here is the CPU temperature that you can see at the top left corner for you guys. It says 13 degrees Celsius. That's around 30 degrees Fahrenheit, I think, in the US. That is lowest temperature you can ever get on a CPU. No system in the world can do that. And why do we need it to go so low? By going lower on the CPU, we both accelerate it, so we make it go faster, and we can actually make it more energy efficient. End of demo. So, we took that server you just saw, we put it in our client's location, we ran a similar test, and with our system, we were able to run their computing task almost 50% less time, whilst using only half of the energy. This is a wow moment. Yes, yes. Now, who needs this? In banking, you want to buy stocks, right? You want to make sure you're the first one. You really need fast servers. You're running innovation. Almost every startup here on the stage today uses computing, and to be able to do that, they need fast compute, so we can accelerate their innovation as well. or anything that uses real-time data and needs reliability. I'm Helena. This is my co-founder, Rudy. And together, we're the co-founders of the company. And we have team members with more than 20 years of experience in semiconductors, as well as serial entrepreneurs. Together, we have around 3 more spots left for pilot projects. We're in pilot stage. So if you want to have the world's fastest and most efficient server to accelerate your innovation, then get in touch with us. And by joining us, you will also join us in our mission to cool down the planet one server at a time. That's in cooling.
Elena, that was wonderful. Thank you so much. Milo, let's start with you.
Oh, you're kicking it. I'm kicking it off?
Yeah, you are.
Oh.
It's your turn.
I love it. It's really cool. Great presentation. My question to you is, there are a number of other technologies, I think, working on cooling servers. And I was wondering if you had done any work to evaluate how you stacked up to those other technologies. And they're not only just in cooling, right? Or they're all in the cooling sector, but some of them are looking at having like a unique metal framework on the back of the chips that, you know, dissipates the heat more efficiently. Could you just maybe like talk a little bit about the competitive landscape?
Yeah, so in the CPU world, there are different CPUs. So different cooling methods are necessary. It's not one size fits all. So we're focusing on high performance computing, where you have very high heat densities. And with the cooling systems today, Intel and AMD, they focused on creating the best chip ever, but they sort of forgot about the cooling. The cooling industry is not as interesting as the CPU industry. So essentially, they become really hot, and the cooling systems just simply cannot handle it. So we tested with water, we tested with air. There's also immersion cooling, which is a new thing, but it's for a different application. And in fact, if you put a really high-performance thing in an immersion cooling, it actually might set on fire, so you don't want to do that.
Dave?
Yeah, on the chart that you showed with Moore's Law, each one of those dots along the way was, you know, a chip that was designed by hundreds of people, took many, many years to design, tens of millions of dollars. Are you expecting that you will both innovate on chips and performance of chips and this cooling technology? Or is your vision that the cooling technology is the differentiator and you'll plug into standard chips that are produced by other CPU manufacturers?
So our long-term goal, we are a cooling company at heart, and our long-term goal is to cool. So we started off with the idea that the heat is going to be there, the problem is going to remain, and the way to solve it is actually by going in silicon. So we worked with CERN, where the technology came from, and they spent, I think, $1.2 billion on researching phase change cooling in silicon. So they've done that before, but it's only, again, for different applications. So what we want to do eventually is to work with chip manufacturers, with cooling companies, and integrate it into one, and therefore solve the issue of heat once and for all.
So from a commercial perspective, it would make sense that you do deals with each chip manufacturer, and they incorporate you into their chip design?
Yes, eventually. Right now, we're early stage, so right now we're focused on the chip. So we're working with server manufacturers, but eventually we're setting up the roadmap for CPU.
Thanks.
Jameson?
Terrific. Could you talk a little bit more about this sort of initial go-to-market, and in particular, sort of what do you feel like is the time to being in market, and what have the conversations been with sort of early customers around the barriers to getting there?
Yeah, so right now we are at a pilot stage, so we're actually deploying our first servers into the market. A big barrier at the beginning was pre-pandemic, people didn't realize that we needed compute. You had face-to-face, and it was all great, and then pandemic hit, and then data centers went actually above their limits, and they exceeded what they can do. And then they realized, oh, we need better cooling, we need better compute. So that gave us an opportunity. People reached out to us. We partnered with a data center, for example, installer. We partnered up with them to, when they build data centers, have better servers. We actually deployed already one of the servers already. It's been running for a year, no problems. And that's how we're trying to get into the market through the partnerships.
Got it. Makes sense. Thank you.
Charles?
Can you tell me a little bit about just, you talked about performance, but also just sort of price and how this compares to alternatives on a price dimension?
Yeah. It's always very difficult to pinpoint. It depends, right? If another pandemic hits, the stock is gonna go up, and then it might go down. What we're working together with AMD, for example, and we've worked with Intel, and we're setting at competitive prices. So evaluating what is performance worth is not easy because it changes day to day, but we're setting it according to what the market requires it today. So we're kind of the top league of the server market today.
Great. Emmeline?
Yeah, I so appreciate it. I maybe picking back a bit on the earlier question. As you think about folks like LiquidStack and Asperitas and others who are kind of really creating these closed-loop cooling systems within data centers, do you see yourself integrating alongside those types of folks because you're really kind of cooling at the chip level? And if so, just give us a sense of how that kind of go-to-market motion looks as you're selling kind of alongside some of these players and the investments already made.
Yeah. So what is really different with, for example, Asperitas and the Submer, they really require a lot of new infrastructure. We envision every single data center that's currently running on air cooling can put our server in right away. That's our go-to market. That's where really we had to put a lot of time and effort in making it fully self-sustainable. And that is where we make a lot of difference. Later on, we can always integrate also with other parties.
Super helpful. And then maybe just a follow-up, talk a little bit about the BOM. Like, how much does it cost to actually create the server today, with the device and everything?
The server, yeah, it's pretty standard. As we're working with a server manufacturer, so we get all the components off shelf. What we do is we make our own design in terms of, okay, what specifications. So it's not only the cooling itself, but it's also, we select the right memory, we select the right CPU. So right now we're working with AMD, the up and runner in the industry. So what you saw was 64 cores, so it was extremely, extremely fast. The cooling part is the most expensive, so compared to the competition out there, it's much more expensive, but also the result you get is you cannot get it elsewhere. And what was surprising for us is today you can buy a CPU, it costs around $7,000 or euros, and the cooler that comes with it is $30. So there's a big price difference, and of course, and you're not able to use that CPU to its max capacity that it's designed. So you paid for something, and you're not able to use it. And with better cooling, more expensive cooling, in the end, you still get that money back because it's more energy efficient. You've made your task on time, and if you're an engineering company and you have 200 people working on this, and you save everybody's time an hour a day, that scales and scales a lot.
Well, thank you very much. Give it up for InCooling.
Thank you.